when I compress the spring, what does the ruler want to do? It wants to straighten out. I can't stretch this at all, okay, because you cannot see the effect. Are we clear? Okay, make sure you get this very clear. If you are confused, just bring a ruler and do experiment on the spot. Are we clear? Good, okay. I don't believe in memorizing. I believe in understanding well, okay. When you understand things well, then you remember easier. Are we clear? Okay. Now, so for this case, we are going to do summation of forces in the x direction is equal to m x double dot dot. Okay, when we declare this, this is when we are doing a what? Dynamic system. When you do a static system, you always assume what? Summation of forces in the x direction is equal to what? 0. So over here, again, another difference. This is 2QO4. This is 2PO4. Are we clear? Okay, but the root of it is anything going towards the right is always what? Positive. Okay, the basic principle is the same. What is equal to is not equal to 0. Okay, so from here, you can say, so now we have to determine our equivalent stress. Okay, so our equivalent stress is equal to 2K plus by 2K is equal to what? 4K. Okay. Sorry, I'm having a weird humor on my mind. Why not? Okay. What did Yoda say when he saw himself in 4K? Any idea? HDMI. Okay, anyway. It's okay. Yeah, sorry. Very late on Wednesday on the afternoon. Okay. Now, some of you will say Eugene, right? Some of you will say Eugene. I agree that when I see over here, this is what? Parallel, right? But when I view this set of springs, it seems to be in what? Series, yes or no? Why is it 2K plus 2K is equal to 4K? Why? This is because the analysis is from the what? The body. So the analysis cannot cross. Are we clear? So this is not a good analysis. Okay. So you have to look on either the left-hand side of the body or the what? Right-hand side of the body. You cannot like, I'm happy, left and right. No. Rules that you have to follow. So when now you know, so we are going to draw minus 4K or minus 4KX is equal to mx double dot. So mx double dot plus by 4kx is equal to 0. Okay. So for this case, the resonant frequency is equal to 4k over m. Are we clear? That's it. That's straightforward. Okay. I think more important, what you learn over here is the multi-body what? Free body diagram. Okay. You can do trusses later on in 2PO4. Same principle is applied. Are we clear? Okay. Nothing changes. Only thing that change is summation of forces is equal to mx double dot dot. Now, do y'all watch the tutorial on Friday? Yes or no? Right? So everything is uploaded. I will try to buy a mic so y'all can talk to me. Even though I encourage y'all to stay at home, I want to have interaction with all of you. Okay. Okay. Let's look at another. Any question with this example? Are you happy or no? Are you okay? If not, let me know. Anything unclear? Good. Next, we are going to look at another example. The next example has numbers in it, so it looks more interesting. So we look at example number 2. So I'm going to get from here, and we have to read, okay, for example number 2. Right. So the okay, it's missing, but okay. The uniform beam is supported at the ends by 2 springs A and B, each having the same stiffness K. When nothing is supported on the beam, it has a period of vertical vibration of 0.83 seconds. Okay. If a 50 kilogram mass is applied or is placed at the center, the period of the vertical vibration is 1.52 seconds. Compute the stiffness of each spring and the mass of the beam. Okay, I think this is a very interesting problem because most of the time we don't know the weight of the beam that's supporting. We can do experiment like this. Are we clear? It's a very interesting thing to do. Okay, right. So we are given 2 cases, but before we go on, are the spring in parallel or in series? And it's very obvious is in what? It is in parallel. So if I were to sketch this, okay, this is equivalent to this. This is K, and this is K, this is M. For this case now, this is just the mass of the uniform beam. Okay, that is the mass of the uniform beam. So the first thing we realize is the spring is arranged in parallel. So immediately we will say what? K equivalent will be equal to K plus K. This will be equal to what? 2K. Okay. So we know that omega n will be equal to 2K over M. Now, some of you might ask, why is it so obvious this is equal to 2K over M? So if we were to write out the characteristic equation, wait, we tend to write it in this form, right? Mx double dot dot plus by 2kx. And this will be equal to what? 0. Okay. So x double dot dot is equal plus by 2k over mx. This will be equal to 0. So the 2k over m, square root of 2k over m, right, is got from there. Are we clear? Okay. So what we are given, okay, so we know this, so we are going to determine all right, we are going to determine the mass of the uniform beam and the just the uniform beam and the stiffness of each spring. Okay, and we are aware that the period tau is equal to 2 pi divided by square root 2k over m. Okay, so when we were to rearrange this, this is equal to 2 pi square root of m over by 2k. Okay, so we are going to have two cases. Okay, so case number one, right? Case number one is without the 50 kilogram mass. Okay, so we are going to let m be the mass of the beam. Okay, so for this case, in case you are not sure, this is known as the beam, and this is our 50 kilogram mass. Okay, so we know that tau, right? Tau is equal to, given to us, right? Without the mass, or without the 50 kilogram mass, is 0.83. Right? And this will be equal to 2 over pi square root m over 2k. Okay, so you rearrange this a bit, right? So you just do 0.83 over 2 pi. The whole thing, you square it, and then you multiply by 2k. This will be equal to your m. Okay, so m will be equal to yes, 0.83 divided by 2 divided by shift pi squared times by 2. 0. Or is equal to 34.9 times 10 to power minus 3k. Okay. Now, another thing regarding when we mark your term test, just a reminder, make sure that your solution is in 10 to power 6, 10 to power 3, 10 to power minus 3, 10 to power minus 6, 10 to power minus 9, or 10 to power 9. Are we clear? Okay. I don't want 10 to power 4. I don't want 10 to power 5. I don't want 10 to power 1. Any idea why? So when you convert, when you put in the units, it's easier. Are we clear? Right? So this is known as what? Giga, mega, kilo, mini, micron, and what? Nano. Okay, straight away. Okay, when I see those, I know what you mean. Yes. Say it again. So okay. If I'm wrong, tell me. You want to put 10 to power minus 5? No. Yep, it's okay. Okay, it's okay to put in micro. Okay. Okay. So we have our equation number 1. Okay. So the next one, we are going to look at case number 2 with 50 kilogram mass added to the system.